Hey, JC here. So I just wanted to give you an update on my upcoming online course on climate change called EPIC, a climate change course. So last week I kind of did a monumental effort, and usually, you know what, it really kind of takes a lot out of me, and I can maybe do one shoot a week. But last week I did two. I shot once on Wednesday night and then on Friday night. And the reason for that is because, as you can see behind me, there's a lot of gear in the middle of my living room right now, which is not very nice. And so I'm kind of trying to finish this as quickly as possible, so I can finally clean up this stuff. Uh, and that's kind of the main reason. So I wanted to give you a little like breakdown of what the course is, so then you know. First of all, where is it available? It's going to be available on Listenable, which is, from what I hear, is kind of a new platform for like audio lessons. Uh, so yeah, I'm doing that. This is already all recorded, but there's one part I have to re-record actually. I have this here, a couple of slides. And the video format, I'm gonna try to put it on Udemy. So I don't know if Udemy is gonna accept it or not. This is the question, a bridge I'll have to cross later. But for now, it's gonna be on Udemy. Definitely not on Facebook, because on YouTube, like nobody watches my videos on YouTube. So okay, I wanted to make it a bit more official also. So Udemy. I wanted to go through the chapter names and just explain briefly what the course is about. In the first lecture, I talked about a cosmic perspective, and I mentioned things like, the of course the universe being huge, and I started with a pale blue dot image, which was an image taken by the Voyager 1 spacecraft in 1990. See, I remember it by heart now since I did it so much. I can even say more. It was taken on February 13th, 1990. It's a famous image of the Earth. The image itself is mostly black, and in the middle there, or kind of in the middle, there's a tiny, tiny blue dot there, and that's Earth suspended there in the vastness of space. And I just wanted to kind of start with the big scales. I talked about the Earth itself being really huge. I mean, the inner core, the outer core, and the mantle. Just these three parts are like almost 98% of the entire Earth. We live on the crust, so we're really, really tiny. Really tiny. It's not, I think. We are tiny, and we should be very humble that we are this, tiny, tiny ants, really. Finally, I talked about the atmosphere, and that again, it's in several layers, and most of the action for people happens in the first layer, which we call the troposphere, and most of the greenhouse gases kind of end up there, and they essentially like act like a blanket, so they prevent heat from escaping back into space, which would normally escape if they were not there, or if they were not there in the amounts that they're in today. So that was pretty much lesson one. I talked about the history of climate change. So again, this one is the history of climate change is roughly 200 years old or so, depending on what you talk about. So it's relatively recent, and here I talked about things like science is changing all the time. A good example is Galileo Galilei. When he looked at Jupiter through his bad telescope, he could see like Jupiter and other dots around it, and he thought, oh, okay, maybe these are stars. But the motion of these objects followed Kepler's laws actually. So he kind of deduced that, oh, okay, so all these smaller bodies actually orbit around Jupiter, and if that's the case, then perhaps Moon orbits the Earth, just, same. And perhaps in that case, the Earth rotates around the sun, which it does. So that was kind of a history lesson here, but anyway, it's interesting. I talked about greenhouse gases, so usually we talk about CO2, and there's a good reason for that. Most of the emissions are CO2, actually, by far. About 3/4 are. But you also have methane and nitrous oxide, and even water is a greenhouse gas. But water typically doesn't stay in the atmosphere for long. It spends there an average of about 9 days, whereas methane spends a couple of years, I think. I can't remember. And carbon spends 300 to up to 1,000 years in the atmosphere. So that's why we talk about carbon a lot, because it's important. I talked about population emissions. So this one is slightly controversial, but not for me. It seems controversial for other people. Basically, the idea goes that if we have more people, then we have more emissions. I don't see what is controversial about that. It's just common sense, isn't it? It's true that, okay, we talk about the carbon footprint. It's true that if, for example, I had a kid, I don't have children at all, but if I had a kid, it's true that my kid would have a very large carbon footprint compared to, say, somebody living in the Mozambique, for example. Yes, that is true. I talked about natural disasters and climate change. So this one was pretty short. It's just, which disasters are made worse by climate change and which ones are not. So these can be things like, for example, volcanic eruptions. There is no evidence whatsoever that climate change makes volcanic eruptions worse or whatever. No. But when you talk about things like tsunamis or floods, droughts, then yes. Well, even tsunami is a bit tricky here. Follow my logic here for a second. The idea is basically because of climate change, because of global warming, the ice sheets and the glaciers are melting, demonstrably melting. In a net, they are melting. So if the sea levels rise, then your tsunami, which, let's say, like, you take the Japan one, which was terrible. Actually, it was about 38 meters in height. I don't know if you can imagine that. It was absolutely a monster. But because of climate change now, because of the rising sea levels, maybe, let's say, just as an example, now the height of the tsunami is not 38 centimeters, but it's 40. And that's how. So the tsunami itself is not a product of climate change. The tsunami itself is a byproduct of an earthquake underwater. You got two plates kind of crushing in very violently, and that creates this thrust of water moving upwards, and then the water has to go somewhere, so it creates these gigantic waves, and then it comes back again and it comes down again. So that's why you have many tsunamis. Usually it's not just one. But yeah, so climate change can make the overall height of the tsunami higher. But things like droughts and floods is much easier to explain because we have shifting weather patterns, and that's certainly true. Okay, I talked about, what is this? Oh, this is just a recap episode because I talked a lot. I talked about the carbon cycle and greenhouse gases. So the carbon cycle, you can find images of it on the internet. It's basically the idea there is energy coming in and energy going out. You have a carbon budget there, and the point there again is that greenhouse gases act like a blanket, like an extra layer, like a kind of the glass of a greenhouse, which it blocks the heat from escaping back out. So that's why the greenhouse can stay very warm. That's the basic idea there. I talked about, what is this? Oh, the greenhouse effect in particular. Okay, so I just kind of talked about that already. I talked about, it's like the thing here is shifted, so it's, I have to read that kind of inverted here. Oh, I talked about human psychology. Yes, so human psychology is very important when we talk about climate change, because the way that we behave, the way that we think, is very, very important, in fact. So this one mostly comes from the University of Yale. So these slides came from there. And I talked about some differences of people. So for example, okay, if you, let's use the 97%, because that's a kind of convenient thing to use here. So among climate scientists, there is an over 97% agreement that climate change is happening and that humans are making it worse. But amongst the people, unfortunately, the regular people, only about half of Americans polled in 2019 think so. So you have a huge gap there, which we have to try to close. And if you ask the people, then another question, if you ask them, okay, well, how many of you think you're going to be personally affected, or your community is going to be affected? Then that number falls to 42%. So people really kind of don't think that it's going to affect them. We don't have a majority there. I talked about climate change and health. This one was pretty tough. This one, again, comes from University of Yale, mostly. There's a lot of potential health issues related to climate change. And finally, I talked about mitigation and vulnerability. Now, this one comes from a course that doesn't exist anymore. It was called Climate Change, and it was offered by the University of Melbourne. And I think the one reason why they took it down is I found that a lot of the data that they showed was now out of date. And so maybe they didn't want to update it, or whatever the reason. So anyway, I did my best to update the figures that I could. Obviously, I'm not a government representative. I have limited access to the information. So in some countries, it's really, really tough to find information, actually. So anyway, I did my best. Look, that's what the course is more or less about. There is really a lot of everything for everyone here. I would say that it's designed more for beginners to intermediate, but there are things here for experts as well. So everybody's welcome. Please check out my course when it's available. It's called EPIC, a climate change course. I'll see you around.